Hello, my name is Tran.
I'm Schwartz.
I'm Christopher Ridge.
Sourya and Naraharisetti. We're seniors at Duke University and we made the ring cutter 3000X. Our project began in fall 2012 following a meeting with OE Enterprises. OE Enterprises is a company in Hillsborough, North Carolina that hires people with physical and or mental disabilities to perform various jobs. Most of their jobs are contracts outsourced by other local companies, and one of their most recent contracts was with Carolina Biological, which involved cutting plastic tubing into 34 1/8 inch thick rings and splitting the rings longitudinally. These rings are used for seedling growth in classrooms, and the slit allows the seedlings to grow. The contract was lost due to incorrect packaging and non-uniform rings being packaged. Therefore, the goal of our project is to design a safe and efficient device that will allow the clients at OE Enterprises to cut the rings into 1/8 inch thickness, split them longitudinally, and package them in groups of 34.
Our first prototype was made using a 3D printer using SolidWorks, which allowed us to make our designs completely on the computer. This actually had all of our three components all into one major component. We first had our slitting tool with a blade that was within the hole, and that made our longitudinal slit. Then the extra portion had our blade cartridge and our channel frame, which allowed it to be cut into 34 pieces.
There are two main flaws, however, that held back this prototype from being our final design. The first of which is there is a large amount of friction when making 34 simultaneous cuts. Therefore, alternative methods were needed to remove the blade box. This blade box, for example, is still stuck within the channel frame and was unable to be removed. Second, a different material was needed other than ABS plastic. As can also be seen here, there were compressive braking marks as ABS plastic was not able to support the full force necessary for the device. So it was important for us to move to a new material before continuing our design. After many prototypes, this was our final device. It begins with a rotating tray which stores the tubing. Next is a slitting mechanism which performs the longitudinal slit in the tubing when it's pulled through. The tubing is then fed into the arbor press mechanism which performs all 34 cuts using a ratcheting arm and a gear mechanism. Once the cuts are made, they fall into a funneling cup which collects them in a small cup at the bottom to allow for easy packaging. The entire device, as you can see, is on a wooden platform to keep it all maintained.
Arbor press assembly is responsible for making the 34 simultaneous cuts. This is made up of two main components. The first is up here, and that is the blade cartridge. This houses 34 individual blades, which then are slid down into a channel frame which holds the tubing to be cut. The channel frame actually has two separate parts that slide together. The tubing is loaded when it is open and closed, and then this is all lowered using a gearbox mechanism, which is up here.
Our finished device was then able to be delivered to OE Enterprises. We had our client Excel use the device. First, he pulls the tubing through the slicer. Then he loads the tubing into the channel frame, pushes it in, locks it in place. He then rotates the ratchet arm, lowering the 34 blades into the tubing and making the 34 simultaneous cuts. If rotating the arm is so difficult, Excel can instead ratchet to make it much easier. Excel can then switch the ratchet arm so that it can go the opposite direction. Now he rotates it back the other direction to pull the blades directly out of the tubing. Excel can then pull the rings out and empty them out of the channel frame directly into our collecting funnel. Then he collects the cup at the bottom and all 34 rings are collected.
Awesome.
I'm Tracy Craven, and I'm the site director with OE Enterprises.
And I'm John Wiltshire. I'm the director of production for OE Enterprises. We want to thank you guys so much for all of your efforts and hard work in being able to create this device for us. Tracy and I have been working with Carolina Biological for quite some time now, right?
Yeah.
And both sites have had trouble doing this planer ring job. So
I think the most exciting thing about this device is it's going to open up opportunities for people who initially could not participate in this project to be able to engage in the work that goes along with this planner ring project. And it's going to allow us to teach new job skills.
Absolutely, absolutely. I mean, the device that you all have designed has been able to cut through all of the problem areas that we've had previously with this, and we're going to be able to keep the job that Carolina Biological has asked us to do, and hopefully be able to expand on it just because of this device. So
Definitely
again,
will improve efficiency and overall quality.
absolutely.
So we appreciate all the hard work you guys have put into the project and getting to know our clients and their needs.